transformation chapter. So the square root graph, right, is only applied onto the y value, just like a reciprocal, okay? So something like this will be outside your syllabus, okay?
Okay.
So much like the sketching of reciprocal functions, all you need to do is to ask yourself a set of like standard questions, and then you will know how the graph will operate, okay? But the questions are kind of different from the days of the reciprocal function, of course. So in general, these are the stuff that you should be asking yourself. So what do you think happens when fx is actually negative?
Asymptote.
You sure? No, it's not.
It just doesn't exist.
Doesn't exist, okay? Because you cannot square root a negative number in the first place.
Yeah.
Okay? So what if fx is equal to 0 or 1?
It stays the same.
Yeah, okay, still equal to 0 equals to 1. What if when fx is between 0 to 1? And when fx is greater than 1, to be precise, okay?
For the first one, it's a smaller value, and the second one, oh wait, no, for the first one it's a larger value, for the second one it's a smaller value.
Okay, you can actually add more stuff. You said it's okay, let's say for number 3, right? It's a larger value, but it is still range bound between
1 and 0.
1 and 0, okay? So
yeah.
So larger than fx, but still between 0 to 1. So the other one will be smaller than fx, but still 1 to infinity, okay? Okay, so on an abstract point like this, you are just going to be dealing with h and square root k, that's all, okay? And then horizontal asymptote, what do you think it will become?
The root of that y value.
Say that again?
Like the root of that y value?
Yeah, that's right. So square root c, okay?
Yeah.
Okay, what about vertical asymptote? Okay, there's a mistake
Stay
here.
the same?
Yeah, this should be x is equal to a. Okay, still the same, still undefined, okay? If it's not defined in fx, it should not be defined in square root of fx.
Okay.
Okay.
So there's no change to vertical asymptotes.
Okay.
Okay. Yeah.
So this is actually easier than it seems to sketch. All right. You can see that the set of listing questions are still there, of course. Okay. The one that is most unintuitive to most people would be this. Okay.
Okay. Yeah.
Okay. So with this, you can sketch one easily. So this one, right? You said negative y values will be outside the picture right away, right? So immediately this gets removed from consideration immediately.
Yeah.
Which can only be a good thing, all right? Okay.
Yeah.
So you will see roots and roots are still roots, right? Okay. Then so it's about how these two viscals behave right now. Okay, let me just remind you, the classic square root x graph, right, should look like this. Okay, it is a similar feel to logarithmic graph in that it converges. Okay, it increases very rapidly between 0 to 1, but from 1 onwards, it's like what you mentioned, it's actually smaller than y is equal to x graph, like this.
Does it start at the origin, like it touches?
Yes, because square root 0 is equal to 0.
Oh yeah. Okay.
So this is the example of like fx versus square root x graph immediately. Understand? Before 1 is actually above, but after 1 it will be below.
Okay. Yeah.
So something like this, if we don't indicate what is the when is y is equal to 1, right? It's up to your free interpretation then. Okay, as long as we have that logarithmic shape, that will do for us. Okay, so let's just say if I really have a 1 down here, in fact having the 1 makes it harder to sketch because you are pressured to make the shape appear more explicitly. Understand? So let's just say if I don't have that thing, right? So it will just be like this and like this respectively will do.
Okay.
Okay, so obviously they intersect at 1, much like the reciprocal function. Okay, then that's it really. Okay.
Oh, okay.
The key is we can't really predict. I can't really predict what the shape will be because it is actually reliant on the original function that you are trying to square root in the first place also, right? If the original function is a increasing at a low rate kind of function, obviously the square root won't be much fanciful, okay? But if the original function was an exponential function increasing very quickly, then the square root graph will see a higher change.
Okay.
Okay, but as long as you can obey this rule of between above 1 and below 1, then you are fine on your overall.
Okay.
Okay, so the $1 million question would be, what is the difference between sketching these two functions actually?
The second one has below the x-axis as well.
Okay, because to sketch this is the same as sketching y is equal to plus minus square root of fx. Okay, so it's the same thing. You only need to sketch this one first, then copy and paste, flip downwards will do.
Oh, okay. So the y-squared thing is basically like doing the root and then just copying it below the x-axis.
So in the spirit of solving equations, right, remember, let's say if we say x squared is equal to 4, then we always, since your grade 7 or 8, they probably taught you like, oh, it's like this, plus minus square root 4, right? Hence it's plus minus 2, right?
Yeah.
So you have kind of been drilled to think that square root and plus minus comes as a pair together, right?
Yeah.
But it's actually not the case at all. When you press square root 4 on the calculator doesn't output you plus minus 2, right?
Oh, it's just 2, yeah.
Yeah, it's just 2, okay? That's why the square root x graph in its original form is just like this. Okay? This plus minus comes about in a, should I say, added version, in the sense that when we look at this on its own, it's actually a degree 2 polynomial, right? A degree 2 polynomial ought to have 2 roots, right?
Yeah.
So this plus minus came from us by adding it in artificially to seek the second. Okay. So hence you have that negative square root x graph like this. Okay. So the key is you should just focus on the positive side of things and then just flip it downwards. Copy and paste, not flip. Okay. That's all really.
Okay.
So this completes your entire transformation question, just chapter. Just like the square root graph and the reciprocal graph, they can be combined together with your stretching, scaling, and whatever stuff. Okay, that's all.
Where does this come in the order of transformations?
So